Some elements on Earth are incredibly dangerous. They are part of the building blocks of our world, yet some carry a power that can destroy life, cause severe injuries, or silently poison humans over time. Today, we are going to explore the most dangerous elements on Earth, and you will be surprised by number 3. Understanding these elements is not just about curiosity. It is about learning how powerful and unpredictable nature can be. These elements are not something we encounter in everyday life in their pure form, but they exist in labs, industries, and in some cases, in our environment. Their danger comes in different forms. Some react violently with air or water, some are toxic and accumulate in the human body, and others are radioactive and release deadly radiation that we cannot see, smell, or feel. It is this hidden danger that makes these elements fascinating and terrifying at the same time. Polonium is one of the most infamous elements in terms of its danger. It is highly radioactive, which means it emits radiation that can destroy human cells at the atomic level. Just a tiny amount of polonium can be fatal. To give you an idea, a few milligrams are enough to kill a human being if ingested or inhaled. Polonium was discovered by Marie Curie in 1898, alongside her discovery of radium. Marie Curie named it after her homeland, Poland, which was a remarkable tribute considering the political situation at that time. Polonium exists naturally in trace amounts in the Earth's crust, but isolating it in pure form is extremely difficult. This difficulty is part of what makes it so rare and so dangerous. Polonium-210, the most well-known isotope of polonium, has been described as 250,000 times more toxic than cyanide. It releases alpha particles, which are extremely destructive if they enter the body. Outside the body, these particles cannot penetrate human skin, but inside, they cause massive internal damage. Over the years, polonium has been involved in high-profile poisonings. One famous case in recent history showed how invisible and silent polonium can be as a killer. Its presence cannot be detected without sophisticated instruments, and there is no visible change when it harms the body. This invisibility adds a layer of fear and mystery to polonium, making it both fascinating and terrifying. Mercury is another element that has been known for centuries for its danger. Unlike polonium, mercury is not radioactive, but it is highly toxic, especially to the nervous system. Mercury is liquid at room temperature, which is unusual for metals. Its shiny, silvery appearance has fascinated humans for thousands of years. Mercury was used in medicine, in cosmetics, and most famously, in hat-making during the 18th and 19th centuries. Hat makers, who were exposed to mercury vapors daily, often developed tremors, memory problems, and strange behavior, which gave rise to the phrase, mad as a hatter. Chronic mercury poisoning, also known as mercurialism, can cause permanent damage to the nervous system. Even today, mercury poisoning remains a risk in areas with industrial contamination. Mercury can also accumulate in the food chain, particularly in fish, which is why health authorities warn against eating certain types of seafood in excess. Mercury reacts with some metals and other elements, though not violently like sodium or fluorine, but its effects on humans make it extremely dangerous. Its long-term, invisible effects make it a silent threat compared to more explosive elements. Fluorine is number 3 on our list, and it is known as the most reactive element in the periodic table. Its chemical reactivity is unmatched, which makes it both useful and extremely dangerous. Fluorine can react with almost every element it comes in contact with, including metals, water, and even glass. Its reactivity is so high that contact with pure fluorine can cause severe chemical burns within seconds. Historically, scientists who first tried to isolate fluorine faced incredible challenges because of its reactivity. Many early chemists were injured in experiments due to unexpected violent reactions. Fluorine is so reactive that it must always be stored in special containers made from materials that do not react with it. In small amounts, fluorine compounds are used in everyday life, such as in toothpaste, where fluoride helps prevent cavities. This dual nature, useful in small doses and deadly in pure form, makes fluorine a unique element. Chemists often call it the queen of reactivity because it dominates almost every reaction it participates in. Despite its danger, fluorine has been studied extensively, and understanding it has led to numerous advancements in chemistry and industry. Other dangerous elements include arsenic, thallium, plutonium, and sodium. Arsenic has a long history as a poison, sometimes called the poison of kings because it was used to eliminate rivals discreetly. It is tasteless, colorless, and easily absorbed, which made it perfect for secretive poisonings. Chronic exposure to arsenic, even in small amounts, can cause skin lesions, cancer, and internal organ damage over time. Thallium is another highly toxic metal that affects the nervous system and internal organs. It was once used in rat poisons, but is now controlled due to its extreme toxicity. Plutonium, a radioactive element, is infamous for its use in nuclear weapons and reactors. Handling plutonium requires strict safety protocols because even a tiny amount of inhaled plutonium dust can cause cancer. Sodium is a highly reactive metal that reacts violently with water, producing heat, hydrogen gas, and sometimes explosions. Sodium may seem harmless in its common salt form, but pure sodium metal is one of the most reactive substances known. Each of these elements demonstrates a different kind of danger, from silent poisoning to violent chemical reactions to deadly radioactivity. Understanding these elements is not just about knowing what is dangerous. It is also about understanding the delicate balance of chemistry in our world. Some of these elements, like fluorine and mercury, are useful in small, controlled amounts, yet deadly in pure or excessive quantities. Others, like polonium and plutonium, are almost entirely hazardous, requiring extreme caution even when handled by trained scientists. The story of these elements teaches us the importance of respect for chemistry, knowledge of materials, and awareness of the risks present even in substances that make up the very fabric of our world. In daily life, we are rarely exposed to these elements in their pure and dangerous forms. Most contact with mercury, fluorine, or sodium occurs in controlled settings, or in small, harmless amounts such as in toothpaste or food. Even so, historical accidents, industrial mishaps, and deliberate misuse have shown just how powerful these substances can be. Their effects can be immediate, like the violent reactions of sodium or fluorine, or delayed, like the slow poisoning from mercury or arsenic. Scientists and chemists spend their careers studying these substances to harness their power safely while minimizing risks. Safety protocols in laboratories, proper storage, and careful handling are essential to prevent accidents. The fascination with dangerous elements goes beyond their chemical properties. Humans are drawn to understanding and sometimes even confronting danger. Stories of polonium poisonings, mercury exposure in hat makers, or early chemists experimenting with fluorine capture our imagination because they demonstrate the incredible power locked within ordinary matter. Each element has a story, from discovery and early experiments to modern applications and dangers. Learning about these elements is like learning a hidden history of science and human curiosity. It reminds us that the world around us, even something as basic as an element, carries potential for both creation and destruction. While some elements are clearly dangerous, others teach valuable lessons in balance. Fluorine shows how a dangerous substance can be harnessed for everyday use, protecting our teeth. Mercury demonstrates that even familiar substances can have hidden dangers. Polonium reminds us of the invisible and silent threats that exist at the atomic level. Sodium, plutonium, and arsenic show that reactions and effects can be both immediate and long-term, affecting humans and the environment alike. The study of these elements is not just chemistry. It is a lesson in caution, responsibility, and understanding the forces of nature. Even in the modern world, these elements remain relevant. Industrial processes, nuclear technology, chemical manufacturing, and medical research all interact with these substances in some way. Scientists continue to develop methods to safely handle, store, and use these elements to benefit humanity while minimizing harm. Each dangerous element also sparks innovation, leading to protective measures, containment strategies, and safer chemical alternatives. The story of dangerous elements is, in many ways, a story of human ingenuity facing the power of nature. In conclusion, the most dangerous elements on Earth are not just chemical substances. They are powerful reminders of the hidden forces in the world around us. Polonium, mercury, fluorine, arsenic, thallium, plutonium, and sodium each have unique properties that make them fascinating and deadly. Some poison silently, some react violently, and some release radiation that can kill without a trace. Understanding these elements is essential for science, industry, and even daily life. It teaches respect for the power of chemistry, awareness of risks, and the delicate balance that allows us to use elements safely. These elements, dangerous as they are also a testament to the complexity and beauty of the natural world, showing us how powerful and unpredictable Earth's building blocks can be. By learning about these elements, we gain knowledge, not fear. We learn how to protect ourselves, how to handle substances safely, and how to respect the forces that shape our planet. Science has given us the tools to understand and manage danger, and knowledge of these elements is a crucial part of that understanding. Dangerous elements remind us that even the smallest parts of matter can carry incredible power, for better or worse. They challenge us to think carefully, act responsibly, and never underestimate the hidden forces in our world.